Hello, good afternoon. Welcome to the webinar. We are in lesson 2 of Introduction to Python. I don't know. And here's my Jupyter Lab notebook, which you probably know. I'm in a folder called Webinar 2. It's for today's lesson. And what do? I click this away. Maybe make that a little bit cleaner. Start a new notebook, and there we are. Okay, that's this. Let's have a quick review of what is a conditional statement. So I bring that into my notebook. I call the cell a markdown cell because it's just text. And I have a review. I execute the code, and then you can see the text that I have. It's a summary of 3 steps that needed to be done when performing a conditional statement in Python. 1 test logical expression. So if this and that, and then if it's true, if it's found to be true, second, add a colon to take a decision. So if it's true, then third, what to do, provide some instructions. Would it print something that's just a placeholder? Any type of coding can be done as long, and if you remember correctly, as long as you indent by a consistent amount of spaces. And if followed by a colon is the first thing. If alternative conditions are needed, you can add them with elif, outdented elif, and then another colon, and then bring your new statements. And finally, for everything else, you can use the keyword else to whatever else you need to do. So that was the conditional statement. And just in the spirit of this, without duplicating anything that's already on the net, an example. Hopefully you can see that from my screen. An exercise if you are given the age of a person. Then the vaccination priority is just a made-up thing. It means nothing. The vaccination priority depends on the age. So you have to take decisions based on the age that you are given. And the 3 conditions that are formulated here is if you're above 70, this is a person to be vaccinated first. If you're between 18 and 70, yes, you're going to be vaccinated, but only later, so secondary. And if you're up to 18, no, you're too young, you're not getting vaccinated at all. And the exercises use a conditional statement to get a suggestion in the form. So what, based on the age, what is to be done with that person? The suggestion is colon suggestion, and suggestion in square brackets means, and here you put the actual text of what you might want to recommend. So let's program this. You can do it with me. And basically the idea here is that you follow the logic behind it. So the algorithmic thinking, what to do with it. So if we have an age, and we need to, the first thing we need to know, of course, what is the age, right? If we don't know the age, there's nothing that we can do in any sense. So let's make a variable called age, and let's give it some random value, 63 or something. And then we formulate thresholds. You can see the conditions are above 70, between 18 and 70 and 18. So there's 70 and 18 as 2 thresholds. So let's define them. Let's define a high risk threshold. And what do we put that? That's 70, right? The high risk, if you're above 70, then you are at high risk. And then a low risk or lower, and I don't know what, low risk threshold. So we need to set that, and that was supposed to be 18, so the age of becoming an adult. So these are the 2 thresholds that are given in from the exercise or from the condition. These are given to us. So now we need to implement something based on this information, the age and the 2 thresholds. And of course we do an if statement because now we want to have a decision maker that depending on your age does different things or gives different suggestions. So if your age is the variable that contains the number. I think I might make that a little bigger. I just see that somebody likes that bigger. If the age is higher than the high risk threshold, so I say larger, and high risk threshold is the variable. If the age is above this threshold, colon, new line, and indent. So what do? We say the suggestion, what to do. The suggestion here, then that's a new variable. I collect this, and we can say vaccinate now. I'm just making up just any text that you like can be put in there, but I say vaccinate now. The suggestion is go and get your shot immediately, right? And then the other thing is another condition. If you are between 18 and 70, how do we formulate that? It's a second condition. So we use if. So that's else if. And now we say high risk threshold is larger or equal to the age. So the age is below that high risk threshold, but at the same time, it's larger than the low risk threshold, right? So it's now in between. So you are less than 70, less or equal than 70, but you are above 18. What to do then? Colon, indentation. And then we have suggestion. What is the suggestion in this case? Suggestion is vaccinate later. So vaccinate, yes, but vaccinate later. That's a suggestion, a nice suggestion. If you are between 18 and 70, and that includes 70. So in the first condition, we have excluded 70. So people that are older than 70 are given the vaccinate now recommendation. That's it. So the only thing that we need to know, what do we do with the young ones? Maybe, I don't know if anyone is younger, of you is younger than this, but the final condition, everything else, we said we capture in else. So if you are neither between 18 and 70, nor older than 70, what to do? So we can just formulate, and the suggestion will be, I don't know, maybe don't vaccinate. If I say don't, do you remember how to do that? Remember that this is a problem, that if I use the apostrophe here, and you also remember how to get around that problem. So don't, I put an apostrophe like the colloquial saying of don't. Let me just complete this, don't vaccinate. And that will be a problem because of the use of that colon for that missing letter. So the way around it is to use double quotes. If the suggestion is put into double quotes, then this single quote will be used as a character only and not as an instruction to embrace the text. So the don't vaccinate for the young ones would be our final suggestion. So let's test this. Let's see if I have some bugs here. I don't know. Let's just run the code and see what happens. Nothing happens. So there's something, surely something is not so perfect. Let's check. The age is 63. So we have an age that is smaller than the high risk threshold and is above the low risk threshold. Oh, so it should actually work, right? It should actually show the suggestion vaccinate later. Why is it not doing anything? Because I haven't given any command of doing it, right? I have captured the suggestion, but I have not told it what to do now. Where do we do things? Well, after the if condition is completed. So now we can do print. And because in either case we have captured the recommendation and suggestion, we can work with that one variable and get it out. So what do we do? The suggestion is, this is my text. The suggestion is, and how was it done? What is the suggestion? Comma, we put now as a printout, we put just this variable called suggestion, right? So first you collect the recommendation in the variable called suggestion, and then finally say print suggestion. So now it's complete. Code is complete. Age is 63. Recommendation is vaccinate later. So you are not priority. Let's see. Let's check. We have an old person, which is 93. And we execute the code. And then the recommendation is vaccinate now. And finally, we take a child of age 10. And if somebody's age 10, then the suggestion is don't vaccinate. Right? So you can see basically that's it. That's the whole work process. You get your constants or your thresholds in the beginning, the information that is captured in variables. Then you go through this conditional statement with its various parts. And finally, you do what you want to do. In this case, print a suggestion, which you can then, for example, also combine with the name and have an automated email sent to this person. Please see your GP. Either, oh, don't see the GP, or you see the GP soon or later. Right. So that's it. Hopefully that's clear, because it's repeating what we did last time. Is one small thing in terms of algorithmic thinking that I want to point out to you. So take this whole code, just in a new cell, I copy and paste this whole code as it is. And let's have a look at this second condition here. Do you see what it says? It says else if. So first was tested, are you older than 70? And now if not, what happens if you are not older than 70? Then you are checked whether you are between 18 and 70, right? Up to 70. Well, actually, that's an interesting thing, because we have cut off all the people that are older than 70 already. Actually, you don't need to test whether you are below that high risk threshold. So if I just take that out, what will happen? If I just say, if you are above the low risk threshold, then you get the second suggestion. Let's test it. Let's execute the code. Don't vaccinate a child of 10. And now we have somebody close to the threshold, but not over. That is 60. The suggestion is vaccinate later. And finally, we have somebody who is just above the threshold, 71. Vaccinate now. Right? So we don't need this additional checking, are you below 70? Because we know those above 70, they have already been taken care of. So that's something that you don't need to check again. In a sense, it's easier, but now you see that there's something very dangerous here. If that condition is fulfilled, if the first condition, are you above 70, is fulfilled, then the program will not advance to the other questions anymore. It will say, yes, the if condition is fulfilled, is true, then I do what is following after the true, and I ignore the rest. That's important for your assignment of this lesson. That's why I'm mentioning it. So I have to take care a little bit about how this is interpreted, and you continue. If that first statement is found to be false, you actually continue and go further down. So you need to know this, because then accordingly you can set up your successive checkings. Right. That's it. Let's come to our main part. Just save, close this thing here, make a new notebook, and we're now going to go into arrays. Right, so arrays is one of the core concepts in Python, and there's a lot to be said about dealing with arrays, and we have a look at special types of containers for numbers here, which are sort of the basic built-in Python containers to handle various items, numbers, booleans, integers, floats, complex numbers. What else do we have? Strings, of course, strings, text pieces. Everything can be used in what we do now. And what I will focus on is the list. So let's have a title here with the hashtag. It's called a list in Python. So let's look at list first. And basically, we're going to look at indexing and handling a list that contains multiple items. And first, we do things that are true for different types of arrays. But later, we'll look at some things that are specific for list only. So let's do the generic things first. What is a list? A list is a container, so it's a variable like we had it before. And the difference to the ones that we had in the first lesson, we said a equal 2, something of that kind. Very simple, just containing one integer or one name. Now we can contain more than one item. So the way we set it up is to use square brackets. Even a little bigger. A list square brackets, so you need to be very much aware of brackets. In programming, brackets are part of the syntax and they always mean something. And if you don't know what they mean, you will certainly go wrong. Square brackets for list. So whatever is between square brackets, by default, you might expect it to be producing a list. So let's do some list here. What is it? 1, 2, 3, just a couple of numbers. And you know how we can see the content? You can see the content of that list by saying print my list. And I execute this code. And you can see also in the output square brackets contains 3 numbers, 1 followed by 2 followed by 3. So we have 3 things here, 3 items, as we say. 3 integers in this specific case, and we want to now access them individually, right? Imagining in data science, of course, you have not 3, but millions of data points. Now it's a couple of data points that you want to extract, so you want to say which ones. So if we have in this list 3 items, how do we address them? We say my list. We use square brackets, which now don't mean list, but which mean itemized. So which item, which part of that list do you want? So if you want the whole list, you can use it. You can say all, and the abbreviation for all is the colon. So the colon all list will just give you the whole list. And you know, we can have that easier, as you saw above, so we don't need it, but well, it's still possible to say all. Not very interesting here, but in cases of higher dimensional matrices, like a 5 by 5 matrix, maybe you want to see 1 row only, then you would say all members of 1 row. So the next thing is my list. How do we address the first item in that list? So deep breath, Python is a zero-based language. Whatever you have seen with MATLAB or other programming languages, some don't do that, but most programming languages, and definitely Python, is a zero-based language. So the first item in a list is referred to as item 0 or index 0. So if we say that my list in square brackets of 0, this is the number 1. This is the first item in the list. So the first item has index 0, second item has index 1. Check that immediately, put in index 1 is the number 2. And the last item is index number 2, has the number 3 in it. So that's basic thing. And if you're not yet used to it, please get used to it as soon as possible. Just create arrays of the type that we see today here, or whatever you find in the net, and try to access those members. And remember, you have to start thinking in sort of indices are 1 less than the number that you would see if you just count them starting with 1. And there are some advantages which we'll see later on, but It's for the moment, it's just we have to remember that. Now, a peculiar thing about Python is that my list, the last item in a list, has an abbreviation that is a bit special that you can find out, and it's -1. So -1 in a list means go to the end of the list. We can check it. -1 is actually 3 is the last member of that list, and you can see my list 2 and my list -1 gives you the same output. You either say the third item with index 2, or you say the last item using this notation -1. Actually, if you remember what we did last time in the first lesson, my list 2, we can ask, are they the same? Which would be equal, equal. Is my list 2 the same as my list? And then the reverse handling is -1. Is it the same? Yes, that's true. They are the same in this case, right? So because I know the last item, because there are 3 items, the last index must be 2. So I can check this. My list 2 is the same as -1. So that's a thing to know. And if you are curious, actually, you can actually count backwards. So -1 is just the beginning of sort of a reverse viewing of the list. So you can actually also look at my list -2 and -3, and that will successively give you the numbers as they are seen from right to left. Not that we're using it a lot, but in principle, it's there. And if you remember it, maybe one day you'll find a reason to use that. One problem appears if you try to access a number with an index that is not actually there, right? So, 0, 1, 2 are the indices which have their corresponding integer there. But what we don't have is, for example, something with an index 4. Because we don't have 5 numbers. So if you execute this piece of code, it gives you an error. So that's a bit of an error means, of course, if you have a long piece of code, an error means the program will stop and will wait for you to debug it. So that can be annoying. So one might be curious to avoid this error. But in this case, you learn that if you access a member in a list which is not there because its index exceeds the number of members which are there, then you will receive an error. And the error is, of course, the index error. You can start also to read error messages. First of all, error messages are pink. Can you see pink? Yes, you can see pink or this red background. So this is an error message. You have to do something, otherwise it will not run. So if you have this kind of pink there, don't submit, ask a question on the forum, don't submit. And we read error messages from the bottom. So the last line is the most important one. It says index error, which tells you this error has something to do with indexing. And of course, indexing means whatever followed within the square brackets, there's where you have to look. And then it says list index out of range. So means this index has no corresponding entry. Probably in this case, there are less than, less than 5 numbers in that list. So there you can't access a member with index 4. All right. Let's see a few more things, just a few empty cells here. Let's see how we can now access more than one item of a list in a single go. So we still refer to my list, square brackets, and we remember the colon stands for all of them. So show me all of the members. And now comes, how can we now check only a few of them? So what if we want to see the last 2 members? So we don't want to see the first one, but we want to see the second and the third. So we can try my list. And if we say index 1 to the end, so 1 colon nothing else means 1 everything to the right-hand side of index number 1, and we check what the outcome is, and the outcome is sort of as expected. You get from the first everything to the last member contained in that list. So from 1 to the end will be shown if you use 1 colon. What is maybe a little bit surprising in the beginning, something that we need to learn, what happens if I say colon 2? So colon means on the left-hand side, start from 0. So everything up to, and now we say everything up to 2, right? So what is 2? 2 is the third number in the list, which is 3. So let's check what happens if I execute this code. So you see the 1, you see the 2, but you don't see the item with index number 2, which is 3. So remember, when you do slicing, taking part of the list will obey this colon notation. And if you give a number on the left-hand side, that the item with that index will be included. So it's inclusive on the left-hand side, but it's exclusive on the right-hand side, right? So that index number 2 that you specified is something that will not be shown. So it's half open. Left-hand side will be included, right-hand side will be excluded. And we can check this by saying my list, some other similar example, from 0 to 2. What do you expect to see? You see 1 and 2 only. You don't see number 3. And if you have from 0 to 1, you will see the very first member only, because in item with index number 1 is already excluded because it's specified. And similarly, you can probably also guess what happens if I say -1. Or have a quick thought, what is -1? So you specify the last one, and then what you see is you see everything except the last one, right? Because you specified -1, you just use a different way of specifying the last one. Because it's specified is excluded, but everything up to it is included. So that's slicing, and the important thing is other types of Python arrays like tuple and string will follow the same convention. Right, so what we did so far was we used the indices to refer to the items or members of a list, and we then extracted those, because you can see whenever there's a return here, it means you can also assign them to a variable and work with them. So we have extracted part of the list using slicing. Now we have used the index only. And there is one other way of using the index. No, there's one way, the other way around. Now, if you know the number and you want to know where it is, then what do? Right? Now we have said, given the index, find me the number. But we can also use the number to find where it is located. So let's see my list. So this is for reference. My list looks like this. And what I want to do is I want to find the index of the number, let's say the one in the middle, 2. What is its index? We know the answer, but you get the idea, right? So what is the index of the number 2 in that list? So the way to do is we get a little bit of a feel for the object-oriented programming features in Python. You put a dot, and then you press the tab key on your keyboard. You know, the tab key on the left-hand side is the tab. And when you press the tab after that little dot, then you can see, oh, there's a couple of possibilities that I can access. So there's certain functions or methods that I can apply to that list, so that work on that list. So we'll get to append in a second, but let's have index. So this possibility index dot index means get me the index of. And in this case, an argument similar to the print function. If you remember, arguments go in round parentheses. I can say, get me that number 2. Right? And if I do that, 2 has index number 1. That's the answer. And if I say, get me number 1, that's index number 0, and 3, index number 2. So you can try what happens if you're looking for number 4, you get an error, right? Error, why is that? Because 4, there's no such thing as a number 4 in that list. And of course, now you don't get an index error, you get a value error. The value 4, this is what you provided as an argument here to the index, that value is not found, it's not in the list. So you create an error because you were searching for something that is not there. Of course, that's in some sense, that's a stupid thing, right? So you're somehow curious, is there number 4 there and where is it? But actually that's 2 questions, right? If a 4 is there, then you might want to have its index if it's not there. So to avoid such an error like the one that we have here, what you could do is you could first, before you do this indexing, you could search for whether number 4 is there. And there is a way of doing it. Of course, we have sort of seen it. It's a logical expression. What we can say for, and we can use the keyword in, in, for, in, and then we just say what array you want to for in my list. And if you execute the code, it says false, right? So you could do a conditional statement. You said, if that is not in my list, then do nothing. But if it is in my list, like what is in my list, 1, 2, 3. So if I say 4 in my list, if the answer is correct, if that condition is found to be true, like we did conditional statement, then you can check its index and you can go and find the list index by, as we did above, using .index method. So I shown you how to produce the error, but I also give you a hint of how to avoid it in a generic way in programming when you have more things to do than just doing a one-liner. Right, along the same direction we had before, we had this thing that an index, certain index was not, produced an error because it was not possible to find the index in that list because the list was shorter than the index indicated. You can avoid this by asking the length. And you ask the length or how many items are there in my list by using the function len, L-E-N for length. And you apply that as an argument to my list. And it tells you there are 3 members there. So there's no need to look for indices 3, 4, 5, or 6 because they will produce an error. So that's a quick way of checking. This is the length of my list. And here you can see there are only 3 items there. So look for 0, 1, 2 if you need, but no more. Okay, so you can avoid it by checking the length and then say only if the index is smaller than indicated by the length of the list, then please get me that number that is found at that index and whatever you want to do with it. And of course, remember that the length of the list is numbers like 3. It says there are 3 items there, but you remember Python is 0 index based, so the indices are 0, 1, 2. So don't check for number 3 just because there are 3 members there. The maximal index that you can get is the length of the list minus 1. So that's something to remember. It's important where this 0 actually has consequences. Okay, let's just see one more example of those methods that you can apply. and let's say one that starts with C. So there's this method count. So it means in that list, so the function at the end operates on the array mentioned previously, so count within that list. And what you can do is you can just say count how many instances of number 1 are in that list. And what you will find is there's a single instance of it. So maybe we can make that slightly more interesting by redefining it and saying my list is 1, 2, 3, 4, 5, 6, 3, 1, 2, 6. This is not nicely spaced. So we have a couple of different numbers there. Now, if we say count number ones in that list, we haven't redefined it. So if we define that new list and add the count operation on it, then we will see there are 2 ones in this new list. What else is 2 6s? Let's count 6s. There are 2 6s, and how many 2s are there? There are also 2 2s. And how many 3s are there? There are 2 3s. How about 5? There's 1 5. Now you will immediately ask, what about if I search for 10? No error here. Count is 0. So you get a proper output. The code will not be interrupted. If you search for something that is not there, its count is just returning 0. So the output is 0, and you can sort of just without any hesitation go and count for whatever you wish to look for. So count returns the number of items of that specific value, or in this case, integers with number 10. Of course, if you had a string that is 10, so in quotes, then of course you wouldn't find it if you're looking for an integer. So specifying it like this, it means look for the integer 10. Don't look for the string 10, because it will not search for it, so will not find it. Right, so up to here, everything was very generic. That also applies to arrays that are of type string or those that are of type tuple, which I will not go into much detail, but which I will mention at the end. So let's go again with that previous list. Make it the original one, which was 1, 2, 3. Define it and see if it's true. Just return its contents, my list. There we can see it. And now what we learn is a method that only works on certain types of arrays, namely a method that changes the array. Right? And what we're going to use is the function that you saw previously, append. So append means you add a new member to it. Right? Adding a new member to it will change the list, because now it will be one more member. The last item will have a higher index and all sorts of consequences. So this can only be done on arrays that can be changed. And the way of referring to this has, in technical speak, this has a name, and this is mutability. So mutability comes from Latin, you can change it, it's changeable. Mutability, or the list is mutable. So what we can do, mutability, we can append something to the list. Let's append something to it. Let's append, and in parentheses, as an argument, let's append 55 to it. And because we don't see anything, we need to check its content in the next line. So our new list now, after appending, is 1, 2, 3, 55. And you can do that as often as you like. So if you have my list and you say append, you can append anything. Append anything, right? If you want to append that and see the outcome, what is it? My list. And so you can append anything. This time in a string. 1, 2, 3, 55, anything. So how many members do we have? Remember, checking the length of a list, length of my list. What is the length of my list? Now it's 5. We have now 5 members. And if we want to apply what we learned before, my list item number 4 is anything, right? Just because that's the last thing that I included, and within the quotes, that's counted as 1 item. So that's how lists work. So you can add things to a list, and similarly, you can also remove things from a list. So let's do that immediately, because it's just what we know how things run, right? .r, and then you can see we have reverse. Yeah, you can reverse the contents of a list. That's the one below. Now we do remove, and let's remove, say, 55 and see my list. And then we have the list as previously. You see the previous at the top, 1, 2, 3, 55. Now we have removed 55. So we have removed items by calling its value, right? We have said 55 is what we want to have removed, so that number 55 was removed. And of course, thinking about it, maybe you want to only say the index, like if you know the index. You can also remove things by calling its index. How do you do that? The corresponding method is called pop. So if you use pop, then you're not telling it which value you want to have removed, but you want to pop by index. So let's say this list is very strange. Let's remove this anything at the end. That's an odd thing, right? We have integers, that's nice. Then we have anything, it's just a nonsense. Let's remove it. How to remove it? Its index is whatever the length of the list. It's the last item, so -1 will remove it. And we can have my list shown. We end up with a list which is 1, 2, 3, actually the original one. Okay, so I'm not going to go into many more details. Just a comment. If there are multiple instances, like we had this list before where there were 2 3s or 2 6s, and you say remove 6 or remove 3 respectively, then in each case, the remove method will take away the first instance of that item that you specify. So if there's 2 3s and you say remove 3, then the first of the 3 will be, the first of the 2 3s will be actually removed. And if you do it again, then the second will be removed only. So it takes only one when it removes, and it takes the first one, well, seen from the left, not counting negatively, counting sort of in the positive way from left to right. Right. So this is an important feature. Of course, you change it, you want to add something, you want to remove something, you want to append something. You can also insert, and whatever you find it out, you just play with it and search for methods like using that tab key on your keyboard, and you will see intuitively what's there. It's, most things that you want to do will already have been implemented. And this is possible with lists because they are mutable. So whenever you have a set of data points or a set of items that you want to handle, and you think you might be wanting to change that, like adding new data to it or removing some like outliers in the data or something, think that list is the mutable, is your choice because you can change it. In contrast to, say, tuple, which you can't change, which are immutable. Right. Let's check it. Let's create a tuple. So let's have an immutable type of array. And tuple, if you are not familiar with the name tuple, T-U-P-L-E. And my tuple is created by using round parentheses. So you can have the same items like 1, 2, 3 and assign them to a variable called my tuple. This is now your tuple. And if you call it, then you can see 1, 2, 3, it's just the same as before. And as before, you can refer to those things. You can do, I'm not going to go through this, but you can, oh, my tuple is not callable. What did I do wrong? Can you see what the use of the origin of the error is? I used round parentheses, but my tuple doesn't take arguments. It asks for indices, so you don't do round parentheses, you do it in square brackets, and then you'll be told the last item in this tuple is 3, like we had it before in the list. And the thing that I wanted to show you is my tuple. If you put the dot and you check for which methods are there where you can sort of operate on the tuple, it says count an index. So you can count how many instances of, say, number 1 are in this tuple. You can do that, or you can get the index of, say, number 1. What is the index? Will be 0. But you can't append, you can't pop, you can't remove, you can't insert. All those things are not possible with the tuple. If for some reason you needed to do it, what you can do is you can try to convert it to something that is mutable, right? So if you say list, and list is a function that takes arguments, and you say list tuple, it means you convert the tuple into a list. So if you give that a name, my converted tuple, so that's my converted tuple is list of this. And when you say my converted tuple, you can see now it has square brackets. You have it as a variable. And of course, now being a list, of course, you can put a dot and you get all the access to that functionality that you want to have. So types of arrays are interchangeable in the cases where it makes sense. In some cases, it doesn't make sense, but you can convert a list to a tuple or a tuple to a list. If you want, you can also convert a list with integers to string, where then the numbers will no longer be used to calculate something, but will just represent letters without any numerical meaning. So let's get, in the last minutes, let's get one more thing done. So we'll maybe have not time to look at the date, but that's fine. One thing that I want to mention, just because we are not a course in advanced Python programming, but we want to use Python in order to do data science as soon as possible. The actual type of container that we are going to use from data handling lesson 1 forward is not list, is not tuple, is not string. What we are going to do is Numpy arrays. So just as a quick thing, there is a library called Numpy. And that library has all the functionality to very efficiently deal with large numbers, to do number crunching, to be very fast, to have all the way of handling, converting, transforming, and do any operation that you would like to do. And the way we deal with that, because it's not included in standard Python, we get functionality from that library and activate it. So this is something that we'll soon get used to it. You just import whatever is out there that is useful. And for example, if you include from NumPy import array, then this function array, which is not there by default in Python, you can activate it by importing it. It comes with your Anaconda distribution, so you'll get it. It will just be executed. That's fine. And what we can do that we can apply array to a function that takes an argument, say my list. And if we do that, what we get out is an array. And the reason, let me just take that last minute to show you what the reason is. namely when we have a list which is called my list, right? You know, that's 1, 2, 3. Sometimes what you want to do is you want just double every number. You want to multiply every item in that list, say with 2. So you take the list and you multiply by 2, then what you might expect or what people would like to have is that every item is multiplied by 2. Whereas if you do it on a list, what happens is this. Isn't that strange? 1, 2, 3, comma, 1, 2, 3. So it doubles the list, that is taking it 2 times. But this is not what happens if you operate on a Numpy array. If you have a Numpy array, and you say times 2 and you execute the code, what you get is actually 2, 4, 6 instead of 1, 2, 3. And that goes even farther. So you can do that, take the code, copy and paste it. And so for example, take the power. Now, what is the power? To the power of 2? Yeah, take the square numbers. Right? So if you want to create square numbers or any of these operations, it works in a straightforward fashion with Numpy arrays. So what we'll be doing, we're actually using Numpy arrays for most of our data handling and for all of machine learning. So I give you a link. In the chat box, you find a link to a paper that was recently out there describing why Numpy arrays is basically the most widely used thing in the world, because it's so good and every major data science that uses Python actually operates on Numpy arrays, I would say. Okay, have a look at this. This is just a comprehensible, it's non-technical introduction. It shows you also a little bit how Numpy arrays differ from lists and so on, but we'll come to that in due course. So let me stop sharing my screen. That has brought us to the end of today's lesson. Thank you for watching. Please post whenever you have problems with the assignments. Use the forum or contact Hannah or send me an email. Try whatever means there are. And if nothing else, then upload your assignment. And in 2 weeks' time, we'll get to the last part of this introduction to Python by looking at iterations, for loops, while loops, and how to go through the items in a large array one by one. Thanks for watching and see you next time.